Hey guys, welcome back to another RSK Maths tutorial, and in this tutorial I'm going to be showing you guys how we can determine all of the possible factors of a given number. So for example, what I mean by this task is simply like if we have a number such as 12, we want to determine every single factor of this. And one way to do this would be to just test every number below 12 and see if it divides 12. Like we know 1 divides by 12, so 1 must be a factor. 2 divides it, so 2 must be a factor. 3 is, 4 is. When we get to 5, we know 12 divided by 5 is going to be 2.4, which isn't a integer, so therefore 5 isn't a factor. But carry on, we get 6, and then everything after this is just going to be less than 2, so until we get to 12 itself. And yeah, that gives us all of this number's factors. So this method works when you have small numbers like 12. It's pretty easy to just go through most of the numbers beneath 12 and just check if they're actually divisible, but this method is essentially just trial and error, and it's not very good when you start getting to larger numbers. Like if I recommended 100 and let's just say 160, this is going to have a lot more factors, and it's not very efficient to just try out every number below 160. So I'm going to be showing you guys a method which you can use to determine a number's factors using prime numbers. So first what you want to do is, starting with your number, let's just use 12, we want to write this in its prime representation. And if you don't know how to do that, you can either do it using a tree diagram, just branches. So keep dividing until you're left with just primes, circle the primes, and in the end you'll just have a bunch of primes. These are your prime factors, so we have 2 times 2 times 3, and let's just rewrite this as 2 squared times 3. Okay, so once you have your number in its prime form, let me just rub out this tree. Once you have your number in its prime factorisation form, this is where the magic kind of happens. So what you need to realise is that all of 12's factors can be represented in this form, where essentially, let's just call this generic factor f, we can write 2 to the power of, and then I'm going to put a set up here, this isn't very formal notation, but we've got 2 to the power of 0, 1, or 2, multiplied by 3 to the power of 0 or 1. And you can see that this form, if we just pick a number for the powers, so let's just say we pick 1 and 0, this is the generic form of any of 12's factors, and using these combinations we can generate all of the factors of 12. Reason this works is because, like, if we pick something like, if we pick 2 squared and 3 to the 0, well, what we need to do is we need to pick 3 to the 1 as the complementary factor, because currently we have 2 times 2 times 1, which is 4. So the complementary factor is going to be 3. And yeah, you can see that we're basically dividing out one of these things to get the other factor, dividing that multiple if necessary. But yeah, that's how it works. So essentially we want to write every single possible factor in this form, and then we can pick. So this is similar to expanding a bracket. I'm just going to expand out these sort of sets, if you can call them that, just so we can see them a bit clearer. And if we want to pick all the different, if we want to get every single factor of 12, we just need to sort of pick every single combination within these sets. So similar to how you would FOIL out a few brackets, we can start with the first term. So we'll do 0 times 0 and 0 and 0 and 1. So these give us, let me just write them out here, we get 2 to 0 times 3 to 0. So that gives us 1, the first factor. Then if we do 2 to 0, 3 to 1, this gives us 3. Now if we move on, we get 1 to 0, 1 and 0 and 1 and 1, which give us 2 to the 1 times 3 to 0, also known as 2. And 2 to the 1 times 3 to the 1, which is 6. And finally, we get 2 to the 2 and 0 and 2 and 1, which gives us 2 to the 2 times 3 to 0, which is 4, and 2 to the 2 times 3 to the 1, which is 12. And here we have it. These are all the possible factors of 12. Let's just write all of 12's factors. So, yeah, that was essentially how you figure out every single factor of a number. If I were to do this more generally, let's just say a number n, and first thing we want to do is split it into its prime factors. So let me just write, okay, this is going to be a bit weird if I write it generically. So essentially, if we have a number n, we want to split it into prime factors, and then we want to generate all combinations of possible powers for these prime factors. You guys should know what I mean by that. It's just if we write it 2 to the 2 and 3 to the 1, that's the same as generating these sets where it goes 0, 1, 2, all the way up to number, always starting from 0, and same with 3. And then once you've done that, we've generated all the combinations, and then we want to sort of just generate all the matches between these. If you had a bigger number, like if there was a 5 here which went up to 0, 1, and 2, then we would have a lot more parents, because each one of these would then have 3 more connecting to each of 5. So if we had this 0, 0 pair, that would go 0, 0, but then it could also go to 0, 1, or 2 from 5s. So yeah, it gets bigger exponentially. Not exponentially, that's not the right word, but it gets bigger. The number of factors gets bigger very fast as the number of prime factors increases. But yeah, that was the basic process for determining all of the factors of a certain number. Thanks for watching, and I'll see you guys in a future tutorial. Bye.